All right, so this lesson is just on graphing. So you have the parent function, y equals the absolute value of x. I'm going to write down the key points that we need to transform. So from the parent, 0, 0 is a key point, and 1, 1 is a key point. And from there, we can actually get what we need. So if I look at and say, okay, what's happening here? Look inside, and that affects the x. And so how this transformation is, there's a shift 1 to the right. So we're going to add 1 to the x. Then when I look on the outside, there are two things affecting the y coordinate. We're going to multiply by -1 and add 7. So 1 times -1 plus 7. And then we're going to plot these. So I'm going to find where 1, 7 is. And 2, 6. Let's try that again. So, because I know it folds down, what did I do? So, add 1 and then 7. So I like 1, 7. Did I do this one wrong? So add 1, I like that. -1 plus 7 is 2, 6. One to the right, 7 down, 2, 6. I know this folds down. That's what's confusing me here. So if I had the next point 2, 2, maybe this would be more understanding. Add 1. And then negative, that would be 5, 3, 5. Oh, because I'm like, what am I doing? So 1 to the right and 7 up. Are you saying that in the video? Like, what am I doing? 1 up 7. 1 to the right, 1, 2, 3, 4, 5, 6, 7. Hey. And then the other one was 2, 6, which is right here. And I said, you really don't need more. 3, 5 is fine. From there, it's a line, so it's not going to change direction from there. And then this is the axis of symmetry. It's like a parabola that has that I can reflect over. So I can take it and reflect to the left. And then again, it won't change direction, and you have your graph. What's the domain of this function? And it's all real numbers. What's the range? Is there a ceiling or floor? So the bottom is -infinity, but it goes up to that y value, which is 7, and includes 7. What's the x-intercept? So if I continued it, what would it be? Now, to find the x-intercept, I need to make it equal to 0 and solve it. So can I even solve that? So subtract 7, divide by -1, so it's 7. So that means 8 is one of them. So 8 gives me the answer 0. And then on the other side, it could be -7, so it could be, so if it's -7, it could be -6. So if it's -6, it would also give me the answer 0. The y-intercept, you plug in 0. And the absolute value of -1 is 1, and then -1 plus 7. So the y-intercept 6, and you can see it on the graph. We have one extreme point at 1, 7, the vertex. It's a maximum. This is increasing from the vertex. So from 1 to increasing. So -infinity to 1, it's increasing. And then 1 to infinity, it is decreasing. And behavior. So as x approaches infinity, the function approaches -infinity. As x approaches -infinity, the function approaches -infinity. So both ends go down. All right. 1/4 x squared. The parent function is just x squared. So what are the parent points to that? 0, 0, 1, 1, 2, 4. That will do. Then how do they change transforming it? So look inside. It does the inverse of what you see. So we're going to multiply every x times 4. It's a stretch, a vertical stretch. And that's it. And the y stays the same. So we're going to plot these points, 0, 0, 4, 1, and 8, 4. And then I'm going to reflect them. Nope, that one's going to be up to 4. This way, right? Yeah. So it's going to be a wide looking. This is what's called a horizontal stretch. And when you see the graph, you can see the stretch of the parabola. So we had a horizontal stretch of 4. The domain is all real numbers. The range goes from 0 to infinity, has a floor to it. X-intercept and Y-intercept are at 0. We have one extreme point, and that's a local minimum. It's increasing from 0 to infinity, and it's decreasing from negative infinity to 0. The end behavior. As x approaches infinity, the function approaches infinity. As x approaches negative infinity, the function approaches infinity. Number 3, the parent is just x cubed. So what are the transformations here? So there's a vertical stretch and a vertical shift down 5. So the points I'm going to use are 0, 0, 1, 1. I'm going to use 2 and 8. But I also need the negative ones too to be able to do this. So I need all 5. It's going to be helpful. So to all 5, how do I transform it? So the x's stayed the same because there's nothing inside. You'd see parentheses if the x changed. The y, we're going to do two things. We're going to go 0 times 2 and then subtract 5. 1 times 2 and subtract 5. 8 times 2 is 16, subtract 5. That might be off my graph. Negative 2, that's negative 7. And then negative 16, and this one's definitely off my graph. It's going to be negative 21. So let's graph what we can. So we have 0, negative 5. We have 1, negative 3. We have 2 and 11. I'll be up here. So that's what that looks like. And then negative 1, negative 7, and the other one's like way, way down there. Oh, sorry, negative 1, negative 7's here. And the other one's like way off my graph. But that's what it looks like. What's the domain? So it's all real numbers, and the range is all real numbers. It goes up forever and down forever. The y-intercept's right there. It's at negative 5. But the x-intercept, if I make it equal to 0 and solve it, I would add 5. I would divide by 2 and do the cube root. So it's a really awkward intercept. Add 5, divide by 2, and cube root to get it by itself. There are no extreme points. This is only increasing all the way through. Doesn't decrease. And the end behavior. As x approaches infinity, the function approaches infinity. As x approaches negative infinity, the function approaches negative infinity. So the right end goes up and the left end goes down. All right, turn the page. All right, we'll do one more, and then we'll do a part 2 to this video. All right, the parent function is the square root of x. The parent points are 0, 0, 1, 1, and 4, 2 for a square root. To transform them, the y, we're going to multiply by 3. And then the x, we're going to go negative and then add 2. So negative and then add 2. Negative and then add 2. So negative 1, add 2. That's positive 1. Negative 2, add 2. That's now 0. So we have 2, 0, 1, 3, and 0, 6. Make sure I did that right. Negative 1 plus 2. This one. Negative 4 plus 2. That one's off. 2. Should have been a 2, 6. Negative 4 plus 2. That's a negative 2, 6 or 2, 6? Negative 4 plus 2 is negative 2. Okay. So negative 2 and 6. So we have 2, 0, 1, 3. Why can't I graph? 1, 2, 3. Negative 2, 6. And then the curve. So the square root has been reflected on the y-axis, shifted to the right 2, and then it's been stretched by 3. So 3 different things happening to it. The domain of this goes from negative infinity to that x-coordinate, which is 2. The range from bottom to top is 0, and it goes to infinity. The x-intercept is right there. That's 2. The y-intercept is, we find it? It's here somewhere, right? So if you plug in 0, you get 3 and the square root of 2. It's irrational. Extreme. Well, that one point there is definitely a minimum point, right? 2, 0. It's at the bottom. Increasing. Nope. But it does decrease. Negative infinity all the way to 2. And behavior. So as x approaches 2, that means f at x approaches 0. As x approaches negative infinity, the function approaches positive infinity. All right, so I think that's going to be good for now. So number 5 and on, there'll be part 2 to the lesson. All right, Mr. GMAT, over now.